let's consider 15 divided by 2. So 15 divided by 2. 2 go into 15 7 times and remain 1. So here in this case, 15 called dividend. 2 is called divisor. 7 is the quotient. And 1 is the remainder. If p of x and d of x are polynomial with d of x not 0, then there exists a unique polynomial q of x and r of x, whether r of x equals either 0 or degree less than degree of d of x, such that we can write it in terms of the divider divided by a dividend. We get a quotient and the remainder, and we can write this in two different forms, and we can write in two different forms. The result, we can either write it like this or this. Okay, so let's go ahead and take a look at our first example. Divide p of x by d of x, then express the result in two different ways. Starting with part A, and we will set up the long division. So 6x to the third plus x squared minus 12x plus 5 and 3x minus 4. Okay. So the first thing we take a look is 6x to the third. How many times does 3x go into 6x to the third? 3x go into 6x to the third 2x squared times. So go ahead and multiply this back. 2x squared times 3x minus 4. That gets 6x to the third minus 8x squared. And just like the normal division, we go ahead and subtract the first polynomial with the second. So we go ahead and subtract. So 6x to the third plus x squared minus 12x plus 9 minus 6x to the third minus 8x squared to get 0 plus 9x squared. We bring down the rest. Okay. So how many times? So then the next step is to take a look at how many times the 3x. How many times the 3x go into 9x squared? X go into 9x squared, 3x times. So plus 3x. The next step is to take 3x, multiply back, so that get 9x squared minus 12x. Then subtract. So that gets 0 plus 0, and we bring down the 5. Now note that the degree of 5 is a constant, right? So that is our remainder. So what left over is here. This is the remainder. So let's identify our PQ, R, and D. So we have P, we have D, Q of X. Q is this, okay, and R is the remainder. So we can write this as 6x to the third plus x squared minus 12x plus 5 divided by 3x minus 4 is equal to 2x squared plus 3x plus 5 divided by 3x minus 4, or we can write this as 2x squared plus 5 plus 3x times 3x minus 4 plus 5. So there are two ways to bring it. So let's take a look at the next problem. P of x equals 4x to the third plus 7x plus 9. Note that here we are missing the x squared term. In this one, we're missing x squared term. So we will add in the placeholder that is 0 times x squared. When we do the long division. So you see the reason I want to write it that way pretty soon. So 4x to the third plus 0x squared plus 7x plus 9 and 2x plus 1 go into it. Now start with the first term. 2x go into 4x to the third is 2x squared. So note that we start with the x squared, so we want to write on top of the x squared term, but originally we don't have it. So it makes the problem messy and hard to follow. So we'll put a placeholder that's 0x squared. Then we have somewhere to put our x squared term to keep track of what we were doing. Now we multiply back 2x squared times 2x, that gets us 4x squared. 4x to the third plus 2x squared. Now we subtract. That is 0x to the third. So now we get negative 2x squared. Bring down the rest. 2 go into negative 2x squared. Negative 1x. Negative 1x times 2x make negative 2x squared minus x. Again subtract. So that ax. Then we bring down the 9. 2x go into 8x 4 times. Subtract. We get 5 left over. So here we get our, this is P of x, D of x, Q of x, and R of x. So we go ahead and write our result. P of x divided by D of x is equal to 2x squared minus x plus 4 plus 5 divided by 2x plus 1, or 2x squared minus x plus 4 times 2x plus 1 plus 5. Next thing we want to take a look at is the synthetic division. Synthetic division is a quick method of dividing polynomial. It can be used when the divisor in the form of x minus c. So the divisor is a polynomial of degree 1. So it's a linear. So let's use the synthetic division to divide p of x equal to x squared minus x minus 3 by d of x equal x minus 3. So you can follow this step. You place c in the box on the left. So d of x equal to x minus 3 is in the form of x minus c, then this means c is equal to 3. Or you can find c by just letting d of x equal to 0, x minus 3 equals 0. So x equals 3. This implies c is equal to 3. Okay. We place c in the box on the left and the coefficient of p of x into the box on the right. Okay. If we don't have the term, if we miss in a term, we put the 0 in as the placeholder. But in this case, we don't miss any term. So we get 2, -1, -3. We bring 2 down to the box below. Multiply 2 and 3 to get 6. Then place the result under -1, so into the next column. And then we add this together to get 5. Again, the next process, take 5, multiply with 3 to get 15. We put the result under -3, add this together to get you 12. So this telling us this first part here is the quotient, and the leftover, whatever that is the remainder. And we can write this as the result of p of x divided by d of x is equal to q of x plus r of x divided by d of x. Or in this case, we write this as q of x times d of x plus r of x. So let's take a look at the next example. Divide p of x by q of x using synthetic division. So here, q of x equal to x minus 5. This implies c equal 5. So let's go ahead and set this up. We'll put 5 in one side of the box. So the other side, 3, -12. These are the coefficients of p of x. First step, we bring down 3. 3 times 5, that's 15. -12 plus 15 make 3. Again, 3 times 5 make 15. -9 with 15 makes 6. 6 times 5, that is 18. 18 with 1, that is 19. So here we get this is our q of x. And this is our r of x. I can write this answer up as 3x to the third minus 12x squared minus 9x plus 1 divided by x minus 5 is equal to 3x squared plus 3x plus 6 plus 19 divided by x minus 5. Or I can write this as 3x squared plus 3x plus 6 times x minus 5 plus 19.